All right, guys, let's knock out this review video, test 17. This is a weird one because it actually starts with 6 questions of review. The first 6 are actually geometric sequences, so you'll be using these 3 formulas right here for the first 6. The first one says find the common ratio. Remember the common ratio, you put the second term over the first, and that reduces to negative 1/3. So the first one is negative 1/3. Number 2 says find the 7th term. To find the 7th term, you take the first, I'm using this one. You take the first term, which is 2, times r. R is second over first. 6 over 2 is 3 to the n minus 1 power, so to the 6th power. I'm going to punch that in. I'm getting 1438. Number 3 says find the nth term. Remember, when it says find the nth term, leave the n in. You're just writing the formula here. So I'm saying the nth term is the first term times r. R is 8 over 32, which reduces to 1/4 to the n minus 1 power. Just stop there. Number 4, find the sum of the first 7 terms of that sequence. So that form, I'm using this one now, right there on top. So I'm going to do the sum of the first 7 is the first term, times 1 minus r, which is 2, to this n power, which is 7, over 1 minus 2. I'm also going to punch that in. Now, remember, when I punch it in, I don't usually punch in the bottom, the denominator, because this is, you can do that in your head, it's -1. So I'm just going to punch in the top and then change the sign and be done. So I'm going to punch that in real quick. And I'm getting 381. I'll punch that in. Okay, number 5, find the infinite sum if it exists. So the infinite sum, I'm using that last formula on the top right there. First term is 8, 1 minus r. I should have found r first. R is 1/2. Remember, you can only do this if r is between -1 and +1. So I'm going to get 8 over 1/2, which is 16. And then number 6 is a sigma. Remember, sigma is the best. And we're still geometric here, all right? Because we're geometric, let's go away. I'm going to use this one again. So the first term you get by plugging in the 1 right there. So the first term is going to be, let's see, if I plug in 1, it'd be 12 times 1/3, which is 4. R is always whatever has the exponent, so R is 1/3. So here we go. I'm going to go to the sum of the first 10. Remember how you get the n. You do top minus bottom plus 1. So the first term is 4. 1 minus, I'm going to put another parenthesis here, 1/3 to the 10th power over 1 minus 1/3. I'm going to go punch that in real quick. Okay, I'm using an online calculator, so I'm not sure. I'm getting 5.99989, blah, blah, blah. So close to 6, but 5.9989. I don't have an option. This is on a snow day, so I don't have a chance to like plug in our math frac on the calculator. So that's the sum I'm getting on the online calculator. Number 7, back to permutations. P12, P5. If you want to, I'll taught you this week already, so you know what you're doing. You can just punch this straight in your calculator, which I'm about to do. I'm getting a huge number, like 95,040. I'm gonna punch that in. Okay, number 8, how many permutation letters in the phone if all letters are used without repetition? Okay, phone has 5 letters, they're all different. So I'm really doing this, 5P5. If you want to, you could also do 5 factorial, and 5 factorial is gonna be 120. Number 9, how many 4-digit numbers can be found using those 5 digits without repetition? So that's gonna be, an order does matter. So I'm going, because we're doing a 4-digit number, so I'm going 5P4, and then it says without repetition. Without repetition, you're going to blank. So I have 5 choices for the first blank, 5 for the second, 5 for the third, 5 for the fourth. So really that's the same thing as 5 to the 4th power, which is 625. And the first one is going to punch that in real quick, 5P4. Shouldn't be that difficult. Those are small numbers, only difference of 1. I'm getting 120. So if you can repeat, you're getting 625. If you can't repeat digits, only 120. Number 10, how many permutations letters of the word council are there if you're only taking 4? So council has 7 letters, and you're going to take 4. And again, order does matter. Like if you take COUN, that's different. Well, it tells you permutations anyway. So punching in that my calculator also 7P4. Sorry, it's taking a second. Punching that in. I'm getting 840. And then the fun one, how many different arrangements of the letters of the word Mississippi? Now, when you have things that repeat, letters that repeat, a little bit different. You can't just hit your P button. Count how many total letters in Mississippi It's like, to me, there are 4, there's 11. That goes on my top with a factorial, 11 factorial. Then on my denominator, I'm putting all the letters that repeat. For example, there are 4 i's, so I'm putting 4 factorial. There are 4 s's, 4 factorial. There are 2 p's, I'm putting 2 factorial. Now, when you punch this in, you must put parentheses around your denominator, or your calculator is not going to give you the correct response. Let me punch this in real quick. I'm getting a huge number, which I expected. 34,650. That's a bunch. Okay, now we're going to combinations. It says C8C6. How many combinations of 6 objects taken out of 8 are there? Punch that in, and you're going to get 28. Much smaller numbers here. Okay, 13. There are 16 students in a school club. How many sets of officers? 3 sets of officers can be selected. Order does not matter here. It doesn't matter which order you pick the 3 people in, just that you pick 3 out of the 16. Okay, so I'm going to go 16C3 on the calculator. And let's see if I'm getting 5. That's a bunch. 560 different committees, officers of 3. Number 14 on a test. It's just like 12 out of 15 questions. How many ways can this be done? The question becomes, does it matter which order he picks the 15? Nope. Just that he picks 12 out of 15? Nope, just that he picks 12 of them. The order does not matter. So 115C12. Punch it in. Getting 455 different ways to take that test. That's crazy. And 15 is a huge one if you're a gambler. Number 15 says how many different 5-card hands are possible with a 52-card deck. So if they give you 5 cards out of 52, does it matter what order they give them to you in? The answer is no. You're going to get 5 cards. Doesn't matter which order they come in, you're just getting 5 cards. So I'm going 52C5. And gosh, there's a bunch. I'm getting like 2,598,960. That's a bunch of different poker hands. And 16 to 17, review again. Find the common difference. These are arithmetic. The common difference on number 16, the numbers are going down by 6, so the difference is just -6. That's all you got to do there. Number 17, find the 14th term. Look back at the very top of your paper. I'm going to use this formula right here. First term plus n minus 1 times d, because it definitely says it's arithmetic. So I'm looking for the 14th term. So you do the first term plus n minus 1 would be 13, because I'm looking for the 14th term. And d, what is d here? How do they get from 3 down to 7/3, down to 5/3? Obviously, they're subtracting 2/3. That should be a -2/3. It's decreasing by -2/3, so I'm just going to work that out. That's going to be -26/3. Don't forget 3 is really 9/3. 9 minus 26 is -17/3. And there you have it. Hope that helps. Do great tomorrow. See you then.